I've done it in some pretty interesting places. In the road, right downtown, in a farmer's field, and on an island in the middle of a river. The island was interesting. That was sponsored by a yacht club, and they were helping move a lot of equipment. They were really good help from those guys. And as I was watching load after load of equipment getting loaded onto a pontoon boat, we had to go a couple miles down the river to the island. I'm watching the pontoon boat sinking deeper and deeper into the water with each load that's applied to it. And the water line is getting pretty darn close to the top platform of the boat. And this is looking sketchy to me. And I'm asking the captain, we going to be all right? I don't want to be swimming tonight. And he assures me, he goes, don't worry about it. Boat can handle a lot of weight. He was right. But, it was a scary ride. And then we get to the island, and we had to carry all of this equipment over a sandy beach for a few hundred feet up to where the show was happening. And, I don't think I got paid enough for that gig, but it was a fantastic show. We had a great time. Now, one of the questions that I ask a group when I'm being contacted about providing sound services for them is, what's our stage power situation? And the answer I'd prefer not to get is, yeah, about that. Can we power a band off a generator? Well, of course you can. Generator's no problem as long as the generator can supply enough regulated, clean power for all of your equipment. And there are a few considerations that go through my mind when working with a generator to power the band. So I thought I'd cover that in this video and give you some tips regarding powering your band from a generator. Now, the first primary consideration is how much power do you need? And when I think of the world of generators, I tend to drop them into a few different categories. Starting with portable generators. These are small generators that maybe people use for camping. It's probably got a handle on the top of it and you can carry the thing. It's probably good for 1,000 or 2,000 watts. And when we talk generator watts, I tend to think of those watts as a little bit different than the watts you get from the utility company out of your household wall. Because the utility company has a big generator in the megawatt range, millions of watts. And so you're not going to overload the utilities generator. Utilities generator can provide an enormous amount of power. And the power that's coming out of your wall is limited by the circuit breaker you're attached to, not the utility company and what they can deliver. Whereas a small generator that's rated for 1,000 or 2,000 watts may be able to deliver that 1,000 or 2,000 watts, but it probably doesn't have the same kind of peak capacity that the utility services can provide. When you plug something into the wall at home, you can get a tremendous amount of current out of it for a brief period of time. When you start up a big motor, for example, there's a tremendous surge of current that's required to get that motor going. Or with a power amplifier driving a band, your average power might not be so great, but when the kick drum hits for a brief moment in time, that power amplifier may demand a lot of current. And so coming out of the wall socket, you might be able to get 50 amps, 100 amps for a brief period of time before the circuit breaker pops. But the generator may not have that kind of headroom, so we have to factor that in. Now, a small generator, that 1,000 or 2,000 watt generator, that's sufficient for doing your camping activities, for running a radio and some lights and maybe a small microwave oven. And if you're a small performer, a guy with a guitar or a speaker on a stick and a couple lights and a microphone, and you're doing a show for 25 or 50 people, and you're playing some John Denver songs, or if you're extra spicy, maybe some Bob Denver songs, you'll probably be okay. But if you're a multi-piece band, a 4, 6-piece rock band, got a moderate PA, a little bit of lights, that's probably not going to be enough generator. And we'll get into this a little bit more in detail, but at that point, you're probably going to need to get into a generator that is the kind that rolls around in a cart, that's a little too big to lift. Probably something in the 5,000, 7,000 watt range. Typical portable backup generator. Now, of course, as I say this, you can always go big. There's no issue generally going to a bigger generator than you need. But a smaller generator than what you need can be a problem because it can't regulate the voltage or the line frequency well enough with that much load. And if you have major fluctuations in the power coming in, that could be possibly damaging to equipment. And so with a portable generator in the 5,000 watt range, you can probably run a small band doing a small show to 50, 100 people or so, as long as you don't go too overboard with your demands. And then if you want to do a larger show, like a city block party, where you have a real stage, real PA, and a fair amount of lights, well, now we're going to need some real power. And for that, I think of commercial generators, which are usually bolted onto a big trailer, hauled behind a truck. Probably has a 4-cylinder diesel engine in it, and it's rated for 20, 40, 60 kilowatts of power. That's like 60,000 watts of power. And a generator of that magnitude has enough power to run a couple, 3 homes. And so that's plenty of power to run a medium-sized band show. And when I see a generator like that, I tend to breathe easy because it's got enough power headroom that I know that my equipment is going to get clean, smooth power all night long, provided there's enough fuel to keep pouring in the generator and not have any major worries about damaging equipment. Now, of course, if your band name happens to be KISS and you want to do an arena show with 100,000 people, yeah, that's going to require some power. And we're pushing the practical limits of generators at that point. But for most of us, you can put on a show with a generator, provided you have enough generator. And so the question is, how much power do we really need? Well, one of the issues that is a big issue when working with bands is that the power load is very dynamic. It's changing. Every time the kick drum hits, a big surge of power is required. If you're a contractor and you're using a generator to just power some lights on a construction site, that's a pretty easy deal because the lights are a steady state, easy load, and the generator can regulate that very well. But when the demands are fluctuating all over the place in the generator all the time, that gets into the issue where you need more generator than you might think you would need. And you need a generator that has the ability to very well regulate its output with the demanding dynamic load that's placed on it. And not all generators are equal. Some generators have some really good regulation ability, and others, not so much. I'm a big fan of the Honda generators. In my experience, the Honda generators do a good job of handling varying loads, and the Honda generators, at least some of them, have features in them for delivering large amounts of peak current demand for brief periods of time, so that they can have the ability to start up a big motor that might demand more power than the generator's rated for a brief period of time during that startup. And that kind of feature can be helpful with your band because of the dynamic nature of the load. So how to figure out how much power you're really going to need? When figuring out the amount of power that your band is going to require, we can break the equipment out into some categories. The first category would be things that draw pretty much steady state power, and you can look at the label on the back of the equipment and more or less believe the rating. Let's say things such as your keyboards, effect processors, your mixing board, the fan that's on stage. Those sorts of things are going to draw a fairly steady amount of power, and generally, probably not too much. It's probably not going to be a big factor in your equation. Then the next big power-consuming category would be the lighting. And with traditional incandescent lighting, that's probably your number one demand. I would advise using LED lighting wherever possible because it's so much more efficient power-wise, and you can save a whole bunch of power by using LED lights. Now, there is a plus to incandescent lighting, and that is that they provide a nice, even, steady, smooth power demand. And that can put a gentle load on the generator to get it into its regulation area, so it helps the generator regulate power. So I like to have some incandescent lights on the band just to help the generator stay regulated. So maybe I'll have a couple of par 56 bulbs just as stage wash light. But then for all of the effect lighting on the band, I'd prefer to see LED because one incandescent fixture draws about as much power as maybe 10 LED fixtures. So you can get a lot more mileage out of your lighting power-wise with LED lights than you can with incandescents. And with a bunch of incandescent lamps, that might just blow your power budget and push you into a generator that's beyond what you can practically get into very affordably. With LED lighting, much lower power demands. But still, add up the power requirements of all of those fixtures, maybe 30, 50 watts per fixture. And then the other big power demand category is your audio amplifiers, and to a lesser degree, the guitar amplifiers. Now, hopefully you can encourage everybody on stage to not crank the guitar amps up to 11 and draw huge amounts of power. Let the PA do the heavy lifting. And so maybe you can keep those guitar amplifiers down at a moderate volume where they're really not drawing that much power. But the guitar amplifiers are probably going to be demanding fairly steady state power because the audio signals are very dense. Now, when it comes to the PA system, your stage monitors, that kind of material is much more dynamic. And so you might look at the label on the back of your power amps, and it says this amplifier is going to draw 1500 watts from the wall. And that's a worst case condition. If the amplifier is on a test bench running a test tone at full power, yeah, maybe it's 1500 watts. But if you're playing audio through that amplifier, standard, uncompressed, full-range audio, you're probably only going to be at about 1/3 of that number, with the peaks of the audio tapping up to 1500 watts. But longer term, it's probably just, 400 or 500 watts maybe. And so you have to consider what the program material is to guesstimate how much power the amplifier is really going to be consuming. And on this note, let's talk about the different amplifiers. When I'm on a generator, I have a debate as to whether or not I want to use an old school, heavy 50 pounds or 70 pounds of Class AB power amplifier, or if I want to use a more lightweight digital switching amplifier. There's pluses and minuses both ways. The lightweight digital switching amplifier is more power efficient. They're running about 90% efficient or better, so of the power that goes in, audio comes out and you're not wasting a lot of power. And when watts are precious, that's a good thing. Now, the problem that I've seen with at least the amplifiers I have, it might be specific models that I have, is that the Class D amplifiers that I have seem to be more or less attached directly to the wall circuit. So as the power demands go up, so does the input power demands. And so the amplifier, more or less, draws the amount of current out of the wall as it needs that instant in time to cover the power demands that it's trying to service. And so every time the kick drum hits, boom, there's a huge surge of current demanded from the amplifier from the wall. And those amplifiers can kick up 50 or 70 amps of current demanded from the wall. Now, normally that's not a problem because the power utility company, hey, it can deliver it. The circuit breaker isn't going to pop instantly. It takes a moment. And those demands are very short-lived. But in a generator, can you really deliver that surge of current for the peak demands? Maybe, maybe not. Now, the old school amplifiers that I have, the big Class AB or Class H amplifiers that weigh 50 pounds, if you were to open them up, you'd see in the power supply they have these ginormous filter capacitors. And that acts kind of like the water tower in a town, so that The pump that's delivering water to the town doesn't have to run nonstop every time somebody cracks open a faucet. It's got a big reserve in the water tank. And that's kind of what those capacitors are doing in the amplifier. And so they're a big reserve of energy. So when the amplifier has these peak demands, it pulls them more from the capacitors in the amplifier than from the wall or from your generator. And so those amplifiers tend to be a little less demanding peak current-wise on the generator. Now, the downside of those amplifiers is that they are less efficient. They're about 65% efficient. So 20-30% of the power you put into them is just wasted as heat. And so they're a little more wasteful of your watts. And also, many of those older amplifiers are a bit more voltage sensitive. If the voltage sags down, the voltage inside the amplifier tends to sag down, and things might not work quite so great. Whereas the digital amplifiers and other things with switching type of power supplies, many of those switching power supplies are very tolerant of voltage swings. And whatever the input voltage is that comes in, whatever, they just switch it and deliver pure DC to the rest of the circuits. And that's why a lot of modern equipment that you see, like your iPhone charger blocks, are rated so that they can be used on 100 volts to 240 volts without needing to do any kind of configuration switch changes or anything. The power supplies in there can just deal with whatever voltage comes in and they're happy. And so because of that, the digital amplifiers might work better on a generator situation where your voltage is maybe moving around a little bit depending upon the load. And so the question is, how much power are your amplifiers really consuming? Well, that depends upon how loud the band is. And the loudness of the band and the amount of power they consume is a nonlinear relationship. So something to consider is if you set up your band with your big PA system and you cranked it up to 11, so you're just hitting maximum power right up near the top. Well, you're probably melting the first 4 rows of the audience and drawing a lot of power. But for the outdoor show, you have to ask yourself, can I turn it down and still put on a good show? And I'd say the answer is probably yeah. And can you turn it down to half as loud and still put on a good show that the audience will like? Maybe so. Maybe so. And so if you're doing an outdoor gig with a generator and it's not an enormous show, maybe you can turn it down a little bit. Because if you can turn your volume from full loudness, everything the PA can deliver, to half as loud, that's 10 dB down, well, you've just cut your power requirements by 90%, super significantly. Now, maybe that's too far. Maybe you can turn it down so it's just a little bit quieter. Not a whole lot quieter, but just a little bit, 3 dB down. So instead of your meters pegging up there at 0, now they're touching around -3. That much difference probably isn't going to be very perceptible by the audience, and everybody will still think it's a loud show and it's all good, but you just cut your power requirements in half by doing that. And so if you can just turn down a little bit in terms of audible level, you can make a huge difference in the amount of power requirements, and maybe that puts you into a 5,000 watt generator rather than a 12,000 watt generator. So the question is, how much power are you really consuming? How do you know? Well, you can get a device like this P3 watt meter. These have been around forever. And you plug this into your power source, and you plug your load, which would be your rack of amplifiers or your lights or whatnot, into this side of it, and it will tell you how many amps you're drawing. It'll tell you what your line voltage is, and it will tell you how many watts are being consumed at that moment in time. The unit can also tell you how many kilowatt hours you've consumed, which equates to how expensive the power is going to be and what the overall power consumption over that period of time is. So that's a handy device. So at one of your shows, maybe you can plug this into your amplifiers and see how much they draw. And then when you get a moment, you can move it over and see how much your guitar amplifiers are drawing, and move it over and see how much a bank of lights are drawing. And you can add up those numbers and see what your real power consumption is during a typical show, which will give you some measurable information that you can actually work with. And so this is the P3 kilowatt watt meter. These are super popular. They've been around for a long time, and a good device. But I found a better device, I think, which is this version right here. And I think this is a better device because it's less expensive. It's about half the price. And it has some nice features to it. One of the features is you can put in your cost of electricity per kilowatt hour. You can punch that in here, and it will actually tell you what the cost in dollars is to run whatever you've got plugged into this device. So if you've got a refrigerator sitting out in the garage keeping your beer cold, and there's a question of, is it worth it? Well, plug this in and let it run for a month, and it'll tell you exactly how much it costs to run that appliance. But another great feature of this is that it memorizes minimums and maximums. So if you plug this into your band, hit reset on it to reset everything to 0, and let it run for the night, it will give you a minimum and maximum wattage draw during that period of time. And you can, of course, also see what the current wattage being drawn is in real time. And it will also show you what the voltage is. And so knowing the maximum wattage draw during the evening with this meter, you can pretty well figure out how much generator you're going to need. I'll put links down below if you want to pick one of these up. I think this is about a $15 part, so it's not terribly expensive. And of course, it also has a voltmeter on it, so you can plug this into your generator and see what the current voltage is, which gives you real peace of mind. Or if you see the voltage sagging too much, well, maybe that's a clue to turn it down a little bit or turn off a couple lights and let the generator breathe more easily. So great device. I recommend this one highly. But both of these work well. This one's about $30. This one's about $15. I like that one better, so I'll give you a link for that guy. Now, another thing to consider is that the power coming off the generator might be a little unregulated compared to what's coming from the utility companies. The utility company does a fantastic job of providing steady, clean, well-regulated power, both in terms of voltage and frequency. The 60 hertz line frequency from the power company is so accurate that, well, at least back in the day when we had a lot of mechanical clocks, the clock's time was synchronized to that line frequency. So if the line frequency was off by 10%, your clocks would be off by 10%, and that wouldn't be acceptable. So they do a really good job of regulating the voltage and the frequency. But not so much from a generator. Generators tend to be far less regulated than the utility companies are. The frequency probably isn't super critical for most things, but the voltage definitely is. And so I gravitate towards those name brand, high quality generators like the Honda generators that have a reputation for having good regulation of their output voltage. And when you're plugging a whole bunch of expensive equipment into a generator, that's important to me. So for the safety of our equipment, we want really well-regulated and clean power. So I recommend the use of power strips that have some filtering in them, or maybe those Furman power strips that are inside of racks that have some filtering in them that helps take care of any transient spikes that might come onto the line. But even better than that, a device that I use are power conditioners. And these devices run the power through a transformer that is multi-stepped. So if the voltage rises or falls too much, the unit automatically steps you to a little different winding on the transformer to keep the output voltage nice and steady. And they, of course, also have extensive filtering in the box. Now, these boxes are a little bit expensive, but I think it's good insurance when running on a generator. And I've got a couple of them. They come in different shapes and sizes. Here's an old one. This is a Tripp Lite LC 1200. It's good for 1200 watts through the box. And it just looks kind of like a filtered power strip, but there's a bunch of intelligence in the box and a big transformer that really cleans up the power and makes sure that the output voltage stays within proper range, even if the input voltage has some pretty major swings to it. And so you can find boxes like this, or maybe rack mounts type boxes. that are actual power regulators. And these kind of things can be a few $100s or more. But like I say, I think it's really good insurance when you're plugging into somewhat dubious power sources like generators. And having a box like this gives me a lot more confidence that my equipment that's plugged into this will probably survive whatever happens on this side of the box. Okay, so how big of a generator do you need? Let's say you've added up the wattage requirements of all of your equipment. You've used a meter like this to measure the actual watts consumed of things such as your lighting, your guitar amplifiers, your audio systems amplifiers, and you've read the maximum wattage numbers here, and you added all of that up and came up with a maximum watt figure for your band. And so using that number, we can determine what size generator you need to get. But I would advise getting a generator that is significantly larger than that number. So for example, if that number came out at 3,000 watts, I would want a generator that's at least 5, if not 7,000 watts. Because bigger is always better, and having some headroom is really comfortable. And I know that there are going to be some really strong peak current demands on that generator. And so if the generator is spec'd at just the same number of wattage that the meter is reading, and the meter has a measurement time period cycle of maybe a second or so, it's probably not catching some of those really high demand peaks, and you might be a bit undersized. So my advice is to get as big of a generator as you can practically and easily do so. And I try to reach for one that's maybe twice what you think your requirements are really going to be in order to have ample headroom to handle the peaks. During the show, I monitor the voltage. And again, if you have a meter like this, that's one way of doing it. Some of the power meters in the rack, like a Furman rack mount outlet strip, sometimes has meters on it, and I watch those meters to make sure that the voltage isn't sagging too far below 120 volts or whatever it is in your region. And if I do see the voltage sagging, that's a clue to me that I better back it off just a little bit in order to stay within the safe power envelope of the generator. There are some issues to be concerned about with grounds and outdoors and not electrocuting people, so I'd advise you to look into that as well for safe operation. But with those things in mind, you can definitely put on a show anywhere you want to with a power generator. Make sure to bring enough fuel and have a great show, have a good time, and bring the party to wherever you want to go. So I hope that those tips give you some food for thought if you're going to be doing some outdoor shows and strange locations. And I wish you well, and I hope it works out great for you.